off when the moon has completely covered the sun, and in Dallas, Texas, we are seconds away.
Oh my goodness, I can feel my heart racing. You can hear the crowd getting excited. The birds are chirping and they seem like they're going into their nighttime routines.
Wow. So we are a few seconds away. You can hear the crowds cheering.
Here we go. Oh my goodness. This is absolutely ecstatic.
The darkness is coming over Dallas.
Here we are. Just a few seconds
10
left.
seconds.
Woo! Oh, I'm so excited.
Okay, we are 5 seconds away from totality.
One little bit. It's totally dark here. Deep twilight around here.
Wow. You can hear the crowd.
So the last bit of lights, and we're in totality. Oh my God.
Oh my God.
That is absolutely breathtaking.
Oh my God, Michael. How are you feeling right now?
I am just awestruck. I mean, there's a few high clouds, but the beauty of the corona is clearly visible. You can see that spiky structure just poking out. It is heart-stoppingly beautiful.
Oh my goodness, I have tears in my eyes. I was not expecting this.
This is one of those experiences that you just never forget. I feel so special to be right here, right now, experiencing it, and knowing that people literally across the nation are doing the same thing it's truly amazing.
Wow, let's take a moment to take it all in. This is absolutely breathtaking.
Wow. You can see that spiky structure of the corona. That's indicative of our approach to solar maximum. That asymmetrical nature of the corona happens when we're in solar maximum, and that's going to be happening in about a few months from now. So that means that this view of the corona will never happen again, ever. This is a completely unique view that even if you see a million solar eclipses, you'll never quite see one like this.
So, Michael, you study the sun. What is it like to see corona that you don't normally see?
I mean, I just, there are no words. I spent my life studying this thing, and to be able to see it and feel it is, I mean, it's just tremendous. You can see a prominence in the chromosphere, the middle atmosphere of the sun. It's a pink spot, and that pink loop is what I spent 5 years doing a dissertation on. that one little pink loop, and it's just, it makes it all feel like it's in perspective now.
I can't believe how clearly I can see those pink loops and the structures in the corona.
We can see a few planets out as well. They're brightly shining in the sky, and actually there's a plane racing across the shadow as we speak as well.
And I just want to take a moment to say huge thanks to our telescope operator, Vanessa Thomas, for providing these views. This is just so stunning.
People are applauding here, as you can hear. I mean, I think everyone here is getting exactly what they came for, which is just that sense of your place in the universe. This is our closest star, and being able to see the star like this is truly special.
Okay, we have 1 minute left of totality.
Oh, the time just passes way too quickly.
The next eclipse won't happen across the US for another 20 years, so this really is a once-in-a-lifetime opportunity for a lot of people.
Absolutely. Our friends up in Alaska will see their next eclipse in 2033, so I am like already thinking I need to go there. I mean, it's just, it doesn't matter what I need to do, I just have to go there.
Wow. So we're 30 seconds out. So
goodness.
right before totality ends, our telescope operator, Vanessa, is going to put the solar filter back on. But let's just cherish these last few moments of totality in Dallas, Texas. Michael, what will happen right before totality ends?
So as totality's ending, we'll go through the process in reverse. You'll see maybe a diamond ring, a few Bailey's beads as the sun creeps out of totality, and then we're going to go back into a crescent sun again. Okay, and there's a diamond ring again. So time to put your glasses back on. And
sunglasses back on. Sorry, eclipse glasses back on.
And it's coming back again.
Wow, the slither of the sun.
And you can see shadow bands on the ground right now. It looks like it's almost raining, or you can see the shadow bands racing across the ground as we come back out of totality.
Wow. Whew. Oh my goodness, Michael, that was amazing. I was not expecting to feel so emotional. I still have tears in my eyes.
It just grabs you. I mean, it is unlike anything else. It's as amazing as seeing anything in the natural universe. Like I said, there are no words.
Michael, thank you so much for being with us in this very, very, very special moment.
I feel honored to be here. We truly are in a special place in the entire universe right here, and I'm just so happy to share it with you.
So now let's head back to James at NASA's Kennedy Space Center, who's with the Eclipse moon. He's tracking the shadow moving across the US. James, how are things looking on your end?
Yeah, wow, Joy and Michael, really cool view there. It's insane to see just how dark it gets. It's literally like nighttime there. You can hear the birds chirping in that shot as well in the gardens. Absolutely beautiful. We got a bunch coming up in just a few moments here. Our next eclipse path target here for the NASA broadcast is in Russellville, Arkansas. They're going to have a long window too, 4 minutes and 12 seconds. They're expecting that totality kickoff at 1:50:05 to be exact. Again, you can continue to track this with our eclipse tool here. This is at go.nasa.gov/Eclipse Explorer. You can see just how quickly it's moving. I'm playing this in real time. You can see that shadow. It's already moving very quickly to the northeast. And the fun isn't just for our friends on the path of totality, and there are a lot of people on that path of totality. About 31 million people reside somewhere on that path of totality. But there's a lot of people obviously outside of that path as well too. If I put on this overlay here for the percent coverage, a lot of folks, us included here in Florida, are experiencing that partial eclipse. As always, if you are in a partial eclipse, be sure to be wearing those eclipse glasses to protect your eyesight as you're viewing it. But you can see these bands here are greater than 75% view. So say you're watching up in, Milwaukee here, for example, you've got a great view, almost 100% coverage. You're not quite at totality. 89.4%. Looks like you got good cloud cover there. 20% cloud cover. So hopefully you got a nice view up there as well, too. I've also put on this overlay here to show you just the amount of the duration of totality. You see, a lot of our places are within this middle band right here that are getting more than 4 minutes. It may seem like a lot of time, but as you've seen, just how quickly that can go by. Michael sounds like he wrote his whole dissertation, a 5-year piece, on those just few moments there. This just passes so quickly, and again, if you miss this, the next time you're going to have to wait for this in the U.S. is not going to be until 2045. So again, make sure you're previewing exactly when to expect that peak time of coverage wherever you are in our path of totality, or even outside of that path of totality. So a lot coming up very soon. Again, our friends in Russellville look like they have great coverage there as well too. Only 9% cloud cover, so hopefully they're getting a really nice view. But let's check in with Jasmine up there to see. Hopefully you're looking good for there. How's it looking up in your way up in Russellville?
I'm just looking this way. Everything is looking absolutely fabulous here in Russellville. We could not have asked for better weather. So we are back here in the downtown depot area, and joining us now is heliophysics expert Dr. Patrick Kane, all the way from DC. How are you feeling about your very first total solar eclipse?
I'm incredibly excited. As I'm watching all of the changes, there go the crowd. As I'm watching all of the changes, I'm thinking back to the textbooks that I've read, and so it was all academic before. This is no longer academic.
Yeah, so the feeling is very different than what we might read in a textbook. Patrick, just explain, describe the atmosphere around us as it's changing.
Right now, as I'm looking around, of course, the temperature has been falling for the last 20 or 30 minutes, but the light is dimming, and it's dimming faster and faster and faster. It seems like it's accelerating. The crowd is definitely getting excited. I'm looking around the ground to see if I see the shadow snakes. I don't, but this is just really exciting.
It really is. Honestly, like you said, we're feeling that cooler weather.
Yeah.
The crowd behind us just erupted. We're also feeling them fall a little bit quieter, too.
Right.
So we're going to take a beat of silence as we get into totality. I think we're less than about 15 seconds away. So we're going to also look over our shoulder with our solar eclipse glasses still on until we are in totality. Here we go. Just a sliver of the sun left.
Getting close. Crowd's getting excited.
The crowd, all around us, completely electric.
Going. Wow.
Oh my goodness. Here we are.
Here we go.
And the crowd goes wild.
Oh my goodness.
Wow.
We got some Bailey's beads. Oh,
Absolutely stunning.
that is spectacular. We see Venus over to the side there.
And Patrick, it came and went so quickly, but we did see a diamond ring
We did
at the very
indeed.
beginning there. Can you describe to us what is that?
Sure, that diamond ring effect is due to the moon not being perfectly smooth. It's got mountains, it's got valleys. So just like here on Earth when we see a sunrise or a sunset through a valley, we just watched a sunset through a valley on the moon.
Absolutely stunning.
Oh my.
So you said we could see one planet. I see it right there in the
Yep.
sky. Can we see
There you
any
go.
others as we're looking up?
Yeah, we've got Venus on the over to one side. We've got Jupiter up here to the left of the sun. And there's the
This is
corona.
Absolutely beautiful.
That is spectacular.
Now, you also said that this is happening during what we're calling a solar maximum. Now, Patrick, does that mean that the sun is stronger right now than normal?
Not so much stronger, just more dynamic. It's changing a lot. During solar maximum, the magnetic field on the sun is more chaotic, it's more disorganized. So you see more random directions for the jets of gas leaving the sun.
Right.
That is spectacular. We could see a stream.
All right, we are reaching
Wow.
that halfway mark already, 2 minutes into totality.
There's even just a hint of a diamond ring down at the bottom.
I can see it. Yeah,
the
we're looking
lower
at a
limb. See
diamond
that?
ring from Arkansas, the Diamond State. Now, Patrick, of course, as we've been talking about it, this is part of what we are calling the heliophysics big year. You are a heliophysics extraordinaire all the way from Washington, D.C. So what does that mean?
Okay, so the heliophysics big year started out in October of last year with the annular eclipse. And of course, we take a pause here in the middle to watch this particular eclipse, but then it will end on December 24th of 2024 when Parker Solar Probe passes as close as it's ever going to get to the surface of the sun within 9 solar radii.
Oh, wow. And I'm sure that means a lot to you because you worked on Parker Solar Probe about 20 years ago during its inception. So tell us a little bit more about that.
I worked on a concept study for Parker Solar Probe back when I was a graduate student in around 2002 or so. And back then, the idea was for it to actually dive into the sun rather than orbit the sun. So it was going to be a sun dive.
Wow, that is fabulous. This must be a very full circle moment for you,
This
Patrick.
is brilliant. This is absolutely brilliant. And that diamond ring has been Wait a minute. That's pink. What we are actually seeing is down into the chromosphere now
wow.
of the sun. We're seeing a little bit deeper than the corona. I believe it's because of the pinkish color. We're looking down into the chromosphere, which is the next layer of the atmosphere of the sun down.
Oh, wow.
Wow. Oh my God.
This is like nothing we have ever seen here in Arkansas and like nothing we will see for the next 2 decades, right, Patrick?
That's right. It's going to be 21 years before we see it again here. 2045.
All right, so as we are starting to exit totality, of course, we're going to be very careful with our eyes if needed. We're going to put those solar glasses back on, of course. And the crowd just erupting, falling quiet again as they watch this magnificent
Wow.
moment
I am
take
actually
place.
seeing bats flitting through the air.
Oh, wow. Well, we will be very careful then.
Well, yeah.
And why is that, Patrick? Again, those nocturnal animals are coming out, right?
As
They think
far
it's
as they're
nighttime.
concerned, it's nighttime. It's time to feed. So they're coming out to feed on all the mosquitoes we've been swatting.
Okay, got it. We'll be very careful for all those nocturnal critters around us right now.
All right. We are getting closer. Get ready to put those
All
glasses
right, all
back
right.
on.
We're putting those glasses back on. The crowd is,
my
wow,
God.
a second diamond ring seen from right here in
Beautiful.
Arkansas, the Diamond State. Absolutely stunning.
Outstanding.
Beautiful. Patrick, we're going to turn around now and just one question I really do have to ask you before we let you go is, are you team sun, moon, or earth?
I am Team Sun. Team Sun all day long.
Fantastic. I figured from a heliophysics expert like you. We want to thank the city of Russellville for hosting us, Arkansas Tech University, and our telescope feed operator, Joe Mattis. Thank you so much. Now, let's get back to James Traley over at Kennedy Space Center. James, back to you.
Yeah, thanks so much, Jasmine. What have you guys had there? So you were just right here in Russellville. You can see that shadow has now officially moved off and is on our way to our next target, which is up here in Carbondale. Carbondale is one of those very lucky cities because back in 2017, they were right at that intersection point of the 2017 eclipse across America. They're there again this year, but the difference is they're going to have a much longer slot. In 2017, they only had 2 minutes, 40 seconds, and that's not as much as they're going to have this year, which is 4 minutes and 10 seconds in the totally eclipsed sun. A really great viewing window for them to really take in this big moment. Very exciting to be able to track that for them as well. And also some details about this tool here as well. If I click onto their eclipse time here of 1:59:15 local time, you notice this little icon comes up here. This is actually simulated based off real data from the Parker Solar Probe of what we expect the corona around the sun to look like. And as you just heard, the sun's a lot more active this time around. It's kind of like a wild hairball, if you will. Lots of different streamers and things streaking off the sun. So you've been seeing already in our coverage some really cool activity around that sun's corona. If you're really lucky and the timing is just right, you might get a coronal mass ejection streaking off the sun. Glasses at the ready to be able to observe that partial eclipse. This is going to be going on for a while, but for now, let's take a look at Carbondale and see up close what it's looking like. How is it looking over there in Carbondale?
Couple more minutes.
Well, the crowds are going nuts here in